They had initially thought they were going to, or Thomas Brown had promised the Ebbw Company he was going to produce something like 50,000 tonnes of ore. He had no idea whether they could actually do so. In reality, the Ebbw's own geologist had been out here and said, whilst it looks as if there is iron ore available, in my opinion, it is unlikely to be continuous or in the quantities that you expect. Thomas Brown was an extremely arrogant industrialist at the time and said, well, in that case, I will use my own money and invest, and I will prove you all wrong. In reality, that was not the case. They never did produce that quantity of ore in the whole of the 30-year period of time. But coming back to here, this is the, say, Rallis Cross mine, the largest mine on the hills, and this had a shaft, and we'll see where the shaft is. Just in front of this little tree you'll see a depression going into the ground. It's a drift shaft, that is, it's not a vertical shaft, it runs down on an angle, simply because the iron ore pockets run down at an angle. They dip to the south, they also dip to the west, and the way they exploited here was to go from the surface down. The problem with that is that whilst you're following the ore pocket, you're having to bring everything to the surface, and that includes all the water as well that accumulates. And once they were down just around the 100 feet mark, you're into the water level. And initially there was only a what we call a semi-portable engine located, which had to do both pumping and winding. That reached its capacity and they had to provide another engine. So in 1860, a twin cylinder engine was constructed here. And this, all we see at present is just the base, the very low levels. There would have been masonry probably extending way up here. And then on the top of it would have had the twin cylinder winding engine with a central drum. And that drum ran across in line with the shaft. And it's unlike a lot of the colliery or Cornish mines, there was no head frame here. It was just drawn up onto a gantry. And the gantry allowed the railway, which ran where we're standing at present, through here. A branch of the railway came through that hedgeway, crossed the road. There was no crossing gates because this was only a drover's track. So there was no requirement for any gates. And that line came through underneath this gantry, so the ore could be wound up to the gantry, the little trams disconnected and then tipped into the open wagons that were passing underneath. But that engine also had to do pumping as well, and that would have been operated by what we call flat rods, and the rods would have run along the surface on rollers and then went down the shaft to operate the pumps. By 1865, the depth of this mine was such that it had exceeded the capacity of that engine, and therefore what they did was to bring in a second engine, a pumping engine, in 1865, and it was situated just to that bump you see is where the base of the engine was. And this was a 1865 was something like a 51 inch diameter cylinder. And there's a picture here we can see of the buildings as they were derelict at the turn of the 1900s. We're currently standing just in front of the base here of the winding engine, and this was the pump engine, and it had been previously a blast furnace engine at the Ebbw works. 1865 they took delivery of a much bigger 72 inch engine that had been cast in Cornwall from the Perron foundry, and which made their old blast engine redundant, and they brought that across, including all the masonry as well, because this is built of Pennant sandstone, not local stone, and had to erect it on that side. One of the reasons being is that there's workings to the east, so the ground was unstable. There's also the workings to the south that are unstable, and the only piece of ground they could site it on was this piece to the west, which means that the engine is not ideally placed because it's at right angles to the shaft. They couldn't put it to the north because it would have fouled the winding engine, so they had to compromise it in its position. The shaft extends down and goes down something like 650 feet when it started to run out of the ore pocket, because the ore pocket slopes to the west. So they then sunk a second shaft, which is this one delineated by that fencing, which is by that copse of trees. And that shaft, to a degree, is still open. I mean, 35 years ago, I went down that shaft to the first level, and you can get into the first level of the workings. But it's flooded to that level. And as I mentioned earlier, in the 1858, or the winter of 1858, they decided they needed to extend or get the water by an adit, and they started an adit going from the shaft, going north, but also from below Seaview House, coming south. So you had two lots of miners coming in both directions. It's some 1,200 feet to the outlet of that from this point. And Tessa and myself and some others had an opportunity to go down that shaft to the second air shaft where the dam is. But once you get in about 500 feet, you find that the adit is like that. It's not straight, and that's because the two miners didn't line up exactly. Because the only way underground that they could tell which way they're going was to knock on the rock and listen to the guys, and then take a sort of an educated guess. And I'll show you that picture because it shows, this is a plan of the mine. We're currently standing just here in front of the pumping, the winding engine. There's the pump engine. There's the adit. Mark that red line, going right the way out down the hillside. We've come from the winding house, and there's the Beulah Chapel where we've just been. And you can see the kink where the adit doesn't quite line up, but they did join up. The second air shaft is just about here. The first air shaft is right just in front of the house, and that adit runs under the house, under its foundations. But also to the west is the Carnarvon mine, and this is the one where, as I say, initially Nicholas Enner started. He started on these green workings there, very shallow workings, and then later on these were extended, and the two mines connect together underground. All of that and all of this side is underwater, right up to almost the first level in the mine. There's 26 levels in the Rullis Cross mine, and it goes down to nearly 800 feet. The Carnarvon mine was not as deep. There's some 16 levels in that mine, and that's just over about 540 feet in depth. But we have then also here, they had a locomotive shed, because they had to have that to house the locomotive. There was also carpenter's shop, which was needed to prepare all the mine timbers. They had to be cut and taken underground. And then on the back of the boiler house on this winding engine was the Miners' Institute, or the reading room, simply because there was heating from the boiler house, so it was the most comfortable place to be. Now across to the Bampton Road, and all you can see at present is these lumps and bumps, and that was a row of 5 cottages there, one of them being the mine's office, And those are the ones that were built originally by Ebenezer Rogers and Thomas Brown in the very early days of working. And I say they're briefly shown in that picture, but they were in a derelict state and they were slate hung. The roofs have gone and all you've got is the dividing walls that are shown on those cottages. Come the 1907 period, the Mineral Syndicate came across here, blew up these buildings because they wanted the masonry to counterbalance the incline, just to get it to work. But fortunately the date stone, and there's a date stone on the chimney there, and there must have been one on this building, those are the two that are incorporated in those gate posts.
You said they were hoping for 55,000 tonnes?
Or in excess of 50,000.
What did they actually get in the end?
The most they ever produced in 1 year was 46,000 tonnes. That was the best ever.
Oh, it wasn't that far off what they were hoping for.
But on initially here, like the first couple of years of working, 2,000 tonnes, 4,000 tonnes, relatively small amounts.
When you think it was dug out by hand as well.
All dug out by hand.
I was curious about this little groove cut in the rock here. Did that serve a purpose?
The groove is actually what we call a crawlway, and because the engines would have needed foundation bolts for anchoring down the various bits of machinery. So what happens is you have a bolt coming down through the masonry, and then underneath it, it needs a cotter pin that's slid in and a packing piece, and the nuts are tightened at the top so it's pulling up. The basis, of course, is that when you've got an engine on a base, it's trying to be dragged. When you're pulling stuff out of a mine, it's the weight is trying to lift the engine off its foundations. So you must have very heavy foundations to counteract that load.
And the vibration as well.
And the vibration. The other thing is, if you take and this is why the pumping engine, we've got no great details on it as such, because none of this site has actually been archaeologically excavated. We would like to do it, but it's a scheduled site, and we can't get here. But Tony Robinson. That engine would have been quite awkward because the pump rods extending down, you take 600 odd feet of timbers, it's quite weighty, and in consequence an engine is not capable of lifting all of it. So you have what's called a balance box at the surface. Also, partway down the shaft you have another balance box which is counteracting, it's working in the opposite direction, so it's relieving the load off of the engine. Also, the limitation on pumps is these are what we call plunger pumps, and they will do about 180 feet, 200 feet head of water before you get to a stage where the weight of water will exceed the burst pressure of the cast iron pipe. So periodically you have a cistern down the shaft that the water comes up into a cistern, and then it's pumped from that cistern to the next cistern and then eventually out. Some of the water would have to come to surface here because both steam engines need water and there is no spring at the surface here, so some water comes to the surface. The majority of the water is discharged out down the drainage tunnel. Interestingly, Seaview House, the first air shaft, also served as the outside privy to the house. And when
a long drop.
It's a long drop. When we went down that shaft, you can get to that first air shaft and look up, and you can see the long drop.
So is that still open, or you've got to get
well, it's in private land, and again, the farmer, it's got what we call a temporary dam in front of it, because it's also used as a cattle trough now for drinking water.
Right.
But we did have the opportunity to go down. Now, very conscious of our time, very briefly, I've got some photographs here underground on this site, which were taken from down in that shaft, but these are now back in the 1970s, so they're a little bit older than you would expect. But it gives you some idea of underground here. You have, that is the width of the load that's taken out. There's 3 explorers walking along, and this is the level, but that's what we call a trading hole, because what they did, they would only put a tramming level about every 5th level in the mine, depending upon the depth of the ore. So what happened is the miners would be mining at all different levels and then using wheelbarrows coming along and then tipping it down a trading hole, and it rattles down from one level to the next to the tramming level at the bottom, and then it's trammed back to the shaft and then wound back up at the shaft. That's looking down that where you, because it's a drift and you slide in, there's only a little tiny gap there now because a lot of rubbish has been tipped down there. You slide into here onto this heap of rubbish, but that's usually the water level. So it's normally flooded up quite deeply.
It would be this year.
Yeah. That was some guys who came down with diving equipment that went down, but it's so contaminated with rotted trees and rubbish. Also, as you go down there, it stirs up all the sediment. They couldn't actually see anything very much. And then we've got, that's what we call a pillar, and that is all iron ore. All that is iron ore. This is the vein of iron ore that they've taken out, but to stop the sides collapsing, they leave a pillar in along, and then eventually, once that whole area is worked out, they usually come back and then rip out those pillars and then don't go back into that area because it will cave in. But it really just gives you some indication of the extent of the workings.